the structures in each set valid contributing structures. In order for us to do these resonances and to see if they're actual resonances of one another or if they're not valid, we have to start with some rules. The first rule for resonance is that we can only move electrons. We cannot move atoms. Only electrons are allowed to move. So if we see that an atom moved, then those two structures cannot be resonances of one another. The second rule is that second row elements such as carbon, nitrogen, and oxygen cannot exceed an octet. They cannot have more than 8 electrons. So if we notice that an element has more than 8 electrons, then we know that this is not a valid contributing structure for the resonance. Let's go ahead and get started. So first we see this structure here, CH2O, and then we look at the right. Is there anything that we can see that is wrong going from left to right? Well, if we will look at this carbon and we count how many electrons it has, let's go ahead and count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each bond has 2 electrons, and there are 5 bonds that this carbon has. So this carbon actually has 10 electrons. Can it have 10 electrons? No, carbon cannot have an extended octet. So this structure is wrong. This is not a valid contributing structure. Let's go ahead and look at part B. We have this structure on the left, this molecule, and this molecule on the right. What happened here? Well, the electrons from this nitrogen went to make the triple bond, and then here the electrons moved to this nitrogen to become a lone pair. So this is what happened. These electrons moved to become a triple bond now, and these electrons moved to give nitrogen a lone pair. Only electrons moved, so the first rule was not broken, and the second row elements did not exceed octet. So if we, for example, if we take a look at this nitrogen, it has 1, 2, 3, 4, 5, 6, 7, 8 electrons. That's fine. This nitrogen has 4 bonds, so that's 8 electrons as well. This nitrogen has 1, 2, 3, 4, 5, 6, 7, 8. Octet was not exceeded, so these two are valid contributing structures of one another. Let's go ahead and look at part C. We see a structure on the left and on the right. How did this happen? Well, if we moved, for example, this bond here, we would have a lone pair here. But where did these electrons come from? Actually, why don't we go ahead and count the number of electrons here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 electrons on the left. How many do we have on the right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Where did these electrons come from? We cannot add or subtract any electrons. The number of electrons must stay the same. They're just moving. So these two cannot be valid structures of one another. And let's go ahead and look at Z. What happened in Z? Well, we see that the molecule changed completely. Here the carbon on the left has 2 hydrogens, and here the carbon on the right has 3 hydrogens attached to it. Now this carbon here has 1 hydrogen and 1 oxygen, and this oxygen has a hydrogen attached to it, but this oxygen does not have a hydrogen attached to it. So clearly, not only electrons were moved, clearly the hydrogens were moved. They basically took a hydrogen from here and moved it here. And we know that for resonance structures, we cannot move atoms. We can only move electrons. So these must be wrong as well. This is Maya Loche from Transformation Tutoring, and I really hope that you enjoyed my video.